I want to continue talking about partial pressure. View how they can serve as concentrations. So functionally, partial pressure is nice. It lets you describe gas mixtures, but really we use it when talking about mixtures of gases instead of a concentration unit. So you can use things like molarity to describe gas mixtures. It's just not very common because a lot of times what we care about in terms of using a gas is the pressure of that gas. And so when we talk about, say, molecules, the types of molecules that are in air, we use a percentage basis, and that's related to the partial pressure. So for example, 21% of molecules in dry air are oxygen. And so that 21%, or 0.21 as a ratio, in 1 atmosphere of dry air, the partial pressure of oxygen is 0.21 atmospheres. So you can see that 21%, basically that percentage of molecules in the air, is the same as the percentage of the total pressure that comes from that molecule, or that type of molecule. And so, standard air, the air that you're currently breathing, is about 21% O2, so the partial pressure would be 0.21 atmospheres. If you wanted, say, more pure, a higher concentration of O2, say like oxygen tanks, that would be 1 atmosphere, say that's given a pressure at 1 atmosphere. Well, it's like 90, the partial pressure would be like 0.99 atmospheres of O2 because it's like 99% of the molecules are O2. So if you have 1 atmosphere of pressure from that gas, if it's all O2, it's a much higher partial pressure of the O2. So for a given total pressure, higher partial pressures imply that there are more of that molecule in the mixture. Time for an example. A rigid box contains CO2 at 0.95 atmospheres. Some N2 is added to the box, and the total pressure increases to 1.45 atmospheres without the temperature changing. What percentage of the molecules in the box are N2? When we're solving, I was going to start by thinking about what is the ending point we're after. We want the percentage of molecules in the box that are N2. When we see that, right away we know that this is a gas mixture. The gas that this N2 is in a mixture, right? Because what percentage of molecules in the box are N2? If it was just N2 in the box, the answer would be 100%. So we know we're inherently looking at a mixture of different kinds of gases here. Because if it's a question of what the percentage is, then we know that we're to be dealing with a mixture. And so everything we know about mixtures, namely that Dalton's partial pressures, are going to certainly be coming into play. So what do we have? Well, one thing to note is there's no other info on the N2. Right? There's no other information about the N2. We don't know what the temperature is. We don't know the number of moles of N2. We don't know the volume of the box. We don't know any other information about the N2, which would give us any sort of potential ability to use like our ideal gas law or Boyle's law or anything else like that. So really the only way forward is going to be to deal with this as a mixture. We're going to have to rely on information about the other gases in this mixture. One piece of information that the total pressure is 1.45 atmospheres. Very nice. We are also told that the CO2 was initially at 0.95, right? This box contains CO2, and then something happens, something gets added to the box, and now we know the total pressure. And the thing is, we formed a mixture of the CO2. So it was initially just a CO2 gas and it had some sort of pressure. Now there's N2 in it. It's a gas mixture. But important to note that the CO2 just becomes a partial pressure, right? It was by itself, now it's in a mixture. The idea of a partial pressure is what would the pressure be if the gas was by itself? Important to note, the conditions that the CO2 is under haven't changed. It's a rigid box, so the volume hasn't changed. And we're explicitly told that the temperature, whoopsies, without the temperature changing, which implies that the conditions the CO2 is under haven't changed, which means that the pressure won't change. So whatever that pressure of the CO2 by itself was, is going to just become the partial pressure of the CO2 in the mixture. So that 0.95 is a partial pressure. We can relate all this stuff using Dalton's law, right? We can use Dalton's law, get all those pressures added together for our total pressure. Let's actually go ahead and solve this then. So we start with Dalton's law. the total pressure, we only have two gases in here, CO2 and N2, so we just add up those two terms. Don't need more terms for gases we don't have. We can rearrange, subtract out the CO2 to isolate the N2, which we're interested in. So then just plug in total pressure was 1.45, the CO2 pressure was 0.95. We can evaluate that to get that the pressure of the N2 is 0.50 atmospheres. So that's great. That tells us the partial pressure of the N2, which is directly related to the percentage of molecules, but we're not quite there yet. In order to get the percentage of molecules, what we do is we just take the percentage of the nitrogen pressure to the total pressure. So when we were looking at, say, air, that's at 1 atmosphere, but here, no gas mixtures don't have to be at 1 atmosphere. So you do need to make sure you get the correct P total to normalize what that total is, what you're taking the percentage of. So we can plug it in, 0.5 atmospheres for the N2, 1.45 for the total, and we find that the percentage of N2 molecules is 34%. So in this mixture, 34% of the molecules are N2. We can also figure out, based on the fact that they have to add up to 100, that the percentage of CO2 molecules is 66, right? They have to add up to 100% because they're the only two gases in this mixture. Participation 630, question 3. On a humid day, up to 5% of the molecules in the air are water. What is the partial pressure of water in 1.0 bar of air under these conditions? This is the third question on participation 630, due Tuesday, June 30th at 11:59 p.m. over on Blackboard. Link to the assignment is right below the links to these videos. Again, on a humid day, up to 5% of the molecules in the air are water. What is the partial pressure of water in 1.0 bar of air under these conditions? Okay, over halfway through this set, couple of videos left. Looking for more questions on participation 630. See you in the next video.